Hello and welcome to NPTEL classes. Today I am here to solve chemistry class 11th NCERT problem 2.21 from unit 2nd, that is structure of atom. Let me read the problem. The mass of an electron is 9.11 into 10 raised power minus 31 kg. If its kinetic energy is 2.18 into 10 raised power minus 18 joules, calculate its wavelength. Problem is based on concept dual nature of matter, and as far as electron is concerned, electron has wave nature as well as particle nature. In Bohr's model of atom, Bohr considered electron as a particle. Later on, de Broglie proposed, or I can say suggested, that like radiation, matter also has dual character, particle as well as wave character, and the wave which is associated with a moving particle is called matter wave or de Broglie's wave. Its wavelength can be calculated using Einstein's mass energy relationship and Planck's quantum theory of radiation. I mean two equations, one E is equal to mc square and E is equal to h nu, and the exact equation that gives the wavelength of matter wave, that gives the wavelength of wave associated with material particle, for example electron in motion, is equal to lambda is equal to h by mv, or lambda is equal to h by p. This equation is called de Broglie's equation or de Broglie's relation. This equation gives the wavelength of matter wave and is equal to h by mv or h by p. Now coming to problem, mass of electron is, here it is fundamental to say that if we have two particles, one small sized like electron and one large sized, h is constant for both, and if we assume that both move with same velocity, then wavelength of matter wave will have inverse dependence on mass. One with small mass will have large wavelength, so wave character is significant. Considering that wave character is significant in case of small sized particles, so this wave character cannot be ignored for electron, as was done by Bohr in his Bohr's model of hydrogen atom. Wave character of electron is to be considered, is to be taken into account in order to calculate various parameters related to atom like energy, and same was done by Schrodinger, who studied wave character of electron, who studied wave motion of electron by building an equation called Schrodinger's wave equation. And after solving Schrodinger's wave equation, we get various parameters of atom, particularly orbital and energy of electron in an orbital. But here problem is based on electron. Electron has small mass, negligible mass, so its wave character is significant. We are interested in in this problem we are interested in calculating the wavelength of the wave which is associated with moving electron in an atom. Mass of electron is given, kinetic energy of electron is given. We have to find wavelength. And in order to determine wavelength, we need to have mass which is given mass is given, and we need to have velocity, which is not given. First we need to calculate velocity, then only we can find the wavelength of wave associated with moving electron. And for calculation of velocity, hint is given because kinetic energy is given. Kinetic energy is given, and kinetic energy is equal to 2.18 into 10 to the power minus 18 joules. In fact, this is the kinetic energy of electron in first orbit of hydrogen atom, 2.18 into 10 to the power minus 18 joules. Mass of electron is also given, 9.11 into 10 to the power minus 31 kg. First I will be interested in calculating value of velocity from known value of kinetic energy. I know kinetic energy is equal to 1/2 of mv square. Velocity square will be equal to twice kinetic energy divided by m. Velocity will be equal to under root of twice kinetic energy divided by m. Kinetic energy is given, mass of electron is given. I simply need to substitute values of kinetic energy and mass, and here I go kinetic energy to twice kinetic energy. Value of kinetic energy is given 2 into 2.18 into 10 to the power minus 18. Mass of electron is given 9.11 into 10 to the power minus 31. I have already done my calculations in order to save your time, and velocity of electron comes equal to 2.16 into 10 to the power 6 meter per second. This is the velocity of electron, which I calculated from its known or given value of kinetic energy. Now I will utilize this value of velocity here in order to determine the wavelength of wave which is associated with moving electron. Lambda is equal to h divided by mv. Value of Planck's constant is 6.626 into 10 to the power minus 34. Mass of electron is 9.11 into 10 to the power minus 31. Velocity of electron is 2.16 into 10 to the power 6. Here also I have done my calculations, and wavelength of electron comes equal to 0.33 into 10 to the power minus 9 meter. This is the wavelength of wave which is associated with moving electron in first orbit of hydrogen atom, 0.33 into 10 to the power minus 9 meter. And if I express this in nanometers, it will be equal to 0.33 nanometer. 0.33 nanometer. So this is solution to our problem. This is answer to our problem. Now, what is its significance? What information this wavelength give us about electron? See, wavelength of electron wave is equal to 0.33 nanometer. If mass of electron is 9.11 into 10 raised to power minus 31, which is true for electron, and if it moves with kinetic energy 2.18 into 10 raised to power minus 18 joules, or else I can say if it moves with velocity 2.16 into 10 raised to power 6 meter per second, then the matter wave which is associated with this moving electron has wavelength equal to 0.33 nanometer, and it lies in the range of wavelength of X-rays. It is in the range of wavelength of X-rays. This is very important information, that wavelength of wave associated with moving electron falls in the range of wavelength of X-rays. Wavelength of X-rays is of the order of 0.01 nanometer to 10 nanometer, and this value lies in this range. So I said that wavelength of wave associated with moving electron lies in the range of wavelength of X-rays, and it is a sort of experimental proof. It is a sort of proof that electron behaves as wave, because its wave length is similar to wavelength of X-rays. So X-rays are waves, so electron also has wave character. One more thing is that X-rays for X-rays, crystals act as diffraction grating. Crystals for X-rays, crystals act as diffraction grating. Crystals diffract, X-rays act as diffraction grating. Or I can say crystals diffract X-rays, and if electron beam also will diffract, if electron beam will also diffract, if electron beam will also be diffracted by crystal, it will act a proof, or it will be an experimental proof that electron has wave nature. Electron is wave like X-rays, I said wavelength of wave associated with moving electron lies in the range of wavelength of X-rays. This in itself is an indication that electron has wave character, because X-ray is wave, electron has same wavelength as that of X-ray, so electron is also a wave. Next I said X-rays are diffracted by crystals. X-rays are diffracted by crystals, and if electron beam will also be diffracted by crystal, it will authenticate that nature of electron beam is similar to nature of X-rays. As X-rays have wave nature, electron beam has also wave nature. Or else I will say that diffraction is a phenomena associated with waves. If crystals diffract electron beam, then it is indication that electron behaved as wave during diffraction, or for diffraction to occur. For diffraction to occur, electron has to behave as wave, then only crystal can diffract electron beam. And the same was proved in their experimental study by Davison and Germer. Name of scientist was Davison and Germer. They allowed electrons to fall on nickel crystal, and what they observed, that this electron beam got diffracted by nickel crystal. Nickel crystal diffracted beam of electrons and received a diffraction pattern similar to that of X-rays, which validated that electron beam behaved as wave, showed wave character. And interesting is that J.J. Thomson also did similar experiments. There again he found that crystals diffract electrons, and for this to happen, electron has to present its wave character to the crystal. His name was G.P. Thomson. These are the fellows who performed experiments involving diffraction of electron beam by crystals. And interesting, I said, is that J.J. Thomson was awarded Nobel Prize. J.J. Thomson was awarded Nobel Prize. J.J. Thomson was awarded Nobel Prize for his contribution in which he showed that electron is a particle, and his son G.P. Thomson was awarded Nobel Prize for his contribution of work in which he showed that electron is wave. J.J. Thomson showed that electron is particle. This won him Nobel Prize. And G.P. Thomson showed that electron is wave, and this won him also as Nobel Prize. J.J. Thomson was father of G.P. Thomson. So both father and son were awarded Nobel Prize, but one for showing electron as particle and another for showing electron as wave. Both were new ideas at their respective times. In times of J.J. Thomson, this was new idea, and in time of G.P. Thomson, this was new idea, and both helped in elucidating the structure of atom thereafter. Class 11th students, let me recall the problem. In the problem, mass of electron was given, kinetic energy of electron was given. We had to determine the wavelength of electron. After reading the problem, we got to know that problem is based on concept dual character of matter, dual character of electron as particle as well as wave. And idea was given by de Broglie, and this equation is de Broglie equation or de Broglie relation. It gives measure of wavelength of matter wave, which is associated with a moving particle. Here particle concern is electron. As electron has negligible mass, small mass, its wave character is significant. its wavelength. We are interested in determining its wavelength, and now we have to utilize this equation. And first thing, we will identify our known parameters and given parameters and parameters which we need to calculate first in order to find value of lambda. H, Planck's constant, is known parameter. Mass of electron is given parameter. Velocity was not given, but from value of kinetic energy we can calculate first velocity of an electron, and I use the expression of kinetic energy in order to determine value of velocity. I was able to obtain value of velocity in terms of value of kinetic energy, and velocity I got is equal to 2.18 into 10⁶ meter per second. Then I am in a position to use this expression. H is 6.626 into 10⁻. I substituted value of H, mass of electron, and velocity of electron, which I calculated in first step. I got wavelength of the wave associated with moving electron equal to 0.33 nanometer. Then additional information, I told that this value is of significance to us because this value of wavelength of electron 0.33 nanometer lies in the range of wavelength of X-rays, and X-rays have the property that crystals, when they strike crystal diffracts these X-rays, and if electron after interaction with crystal will also diffract, if electron beam after interaction with crystal will also be diffracted by crystal, then we will say electron beam behaved in showed same nature as was shown by X-rays. Crystals diffract X-rays. If crystals also diffract electron beam, then we will say that electron beam showed same nature as X-rays. As X-rays has wave nature, electron beam will also show wave nature. And second, I said that X-rays are diffracted by crystals, and for diffraction to occur, diffraction is property of wave, and if electron beam is diffracted by crystals, then electron beam will also act as wave. And these experiments were performed by Davison and Germer and separately by J.P. Thomson, wherein they found they were successful in finding that crystals diffract electron beam as they diffract X-rays, and from here they gave experimental verification or experimental proof to the proposed idea by de Broglie that electron has wave nature, which needs to be taken into consideration, and was taken into consideration by Schrödinger, who studied its wave motion by formulating his Schrödinger's wave equation. And additional, I said that J.J. Thomson told that electron is particle, his son J.P. Thomson told electron is wave, and both father and son were awarded independently Nobel Prize for their contribution in science. Class 11 students, this is the problem which I have got for you today. See you day after tomorrow with one new chemistry problem, as tomorrow is turn of class 12 students. Be blessed. Take good care of yourself. Allah Hafiz.